All right, so this is a problem that I've used in the past with my students, and this is a good example of, using one story problem to cover three different concepts. So in this problem, we have a table, and it says hot water is dripping through a coffee maker, filling a large mug with coffee. The amount of coffee in the cup at time t from t greater than or equal to 0, less than or equal to 6 is given by a differentiable function c, where t is measured in minutes. Selected values of c of t measured in ounces are given in the table above. So the first part says use the data in the table to approximate c prime of 5.5. Show the computations that lead to your answer and indicate units of measure. Okay, so the first thing I want to look at is the table here, and I can see that I'm given an amount of C of T. I'm given ounces. And what we want to find in part A is C prime of 5.5. So that's pointing me to the data in the table and using the average rate of change. So what I want to do is I want to go to between 5 and 6, and I want to calculate the average rate of change. So if I went C of 6 minus C of 5 divided by 6 minus 5, so this is going to be an approximation of C prime of 5.5. Okay? And then so C of 6 is 13.6. C of 5 is 13. 6 minus 5 is 1. So we would get 0.6, and then we have to indicate the units of measure here. So now it's a rate, so this is going to be 0.6 ounces per minute. Okay, so that would be the first concept covered here. Okay, so part B, is there a time t on the interval t greater than or equal to 1, less than or equal to 5, at which c prime of t is equal to 2? Justify fully. All right, so the one thing I teach my students is recognizing the difference between IVT and MVT. So in this case here, when we're trying to prove a derivative exists, we're going to be using MVT, the mean value theorem. And in order to use MVT, this function C must be continuous and differentiable. Well, in the problem, it states that C is differentiable. So since C of t is differentiable, C of t must be continuous. Okay. And then we want to look at the interval that we're given. So we're given the interval 1 to 5. Well, if I take the average rate of change from 1 to 5, I can see that C of 5, let's do this over to the side here, C of 5 minus C of 1 divided by 5 minus 1 is going to equal 13 minus 5 over 4, which equals 2, which is what we're trying to prove. So that means that we can write an argument for MVT here. So what we would say is by MVT, since, and then we would write out our average rate of change here, since C of 5 minus C of 1 divided by 5 minus 1 equals 2, there must be some value t on the interval, and then we write out our interval such that C prime t is equal to 2. Okay? All right, let's try the third part. Okay, for part C, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of 1/6 the integral from 0 to 6 c of t dt. Using correct units, explain the meaning of 1/6 0 to 6 ct dt in the context of this problem. Okay, so we're looking at a midpoint sum with 3 subintervals. So the first thing we have to figure out is what the length of each of our subintervals is going to be. And what we're going to do is we're going to take the limits of integration. So we're going to take 6 minus 0. We're going to divide it by, we want 3 subintervals, so that's going to come out equal to 2. All right, so we go up to our table. So our first subinterval would be here. Well, what's the midpoint? Well, in this case here, 1.15 is in the middle. So the output value would be 5. Okay, so the height of our rectangle would be 5. Now we're going to have the same width each time, so we're going to factor that out. So we get 2 times 5 for the first rectangle. The next interval goes from 2 to 4, so the midpoint would be 10.5. And then our last one from 4 to 6, so the midpoint is 13. And we add the inside the brackets up, we get 28.5 times 2, which is 57. Now we have to take 1/6 of 57, and that gives us 9.5, and in this case here, ounces. All right, now what does this represent? Well, there's a formula, 1 over b minus a, and then if we go from a to b, let's say f of x dx, that represents the average value of a function. Okay, so if I'm going to explain the meaning of this here, since we have the 1/6 out in front of this integral, this means that this gives us the average amount of coffee in ounces. So 9.5 ounces is the average amount of coffee in the mug, and then we would say from 0 less than or equal to t less than or equal to 6 minutes. Okay? All right, I hope you liked the video. Please consider liking and subscribing. I tried to give you 3 concepts here in one problem. Okay, thanks for watching.